Welcome back. Today we're going to be simplifying rational expressions that involve trinomials. So in each expression I have three terms and they are in the form ax squared plus bx plus c. I'm going to factor that first one, n squared plus 6n minus 40. And I like to use the t method. For the t method, you're going to multiply a times c. Well, in this case, my a is just 1, so that's 1 times negative 40. And I want all of the numbers that go into 40. So that would be 1 and 40, 2, 40 divided by 2 is 20, 3 does not divide evenly, so I go up to 4. 40 divided by 4 is 10. Next I try 5. 40 divided by 5 is 8, and then 6 will not go evenly, so I try 7, that doesn't work, 8 does, but it's already in my list. So this is a nice way to list all the factors of a number. And so since this is negative, then I need something that's going to multiply to give me a negative, so they need to have different signs. So I need a positive times a negative or a negative times a positive to give me that negative 40. But at the same time, I need for the factors to add up to be 6. Or in this case, since I have different signs, we really want them to subtract to give us that middle term. So you always want it to subtract to give you b, and in this case, our b is 6. So as I'm looking through the factors, I need for them to subtract. I notice that 10 and 4, if I subtract those, I can get a positive 6. Now because I want a positive 6, that means I do want my larger number to be positive. So I'm going to have a positive 10 and a negative 4. Now because a is 1, these are the factors that go in my parentheses. So remember when you have a trinomial, that's the result of multiplying two binomials. And the only way to get your first term would be to say n times n to get n squared. For 40, there were lots of different options, but we saw that 10 and 4 is the combination that works. Okay, now if a does not equal 1, then you do have to say a times c, and that involves factor by grouping in another video. But if a equals 1, you just take your C, list your factors, don't worry about the sign until you've got them all listed, and then think, how can I get a negative? Well, they would have to be different signs, but you're also going to have to end up with a sum of 6. So in this case, we would end up with different signs, so we're subtracting to get 6. And you can check this. N times n is n squared, n times n, and then negative 4 times n, so that'd be 10n minus 4n is 6n, and then negative 4 times 10 is negative 40. So we're just undoing the distribution or FOIL method that happened to get those two factors. Okay, so that's what's going to go up here at the top, n minus 4 times n plus 10. Now for our denominator, we're going to need to factor n squared plus 18n plus 80. So again, my a is 1, so I just need factors of c. So c is 80. So start with 1, 1 and 80, 2 and 40, 3 doesn't go, but 4 does. 80 divided by 4 is 20. Move up to 5. 80 divided by 5 is 16. 6 doesn't go, 7 doesn't go evenly, but 80 divided by 8 is 10. 9 doesn't go evenly, and we already have 10. So it lets us know we can stop. So since this is positive, if your C is positive, so if you have a positive C, then you need same sign to be able to get a positive 80 out of your factors. Now, if C is positive, then you're also going to be adding to get positive 18, that middle term. Okay, so our B is 18. So I'm looking through this and I see 8 and 10 would give me 18 if they have the same sign. And I need a positive 18, so I'm just going to make both of these positive. And so now I would just put those in my parentheses. The way to get our first term would be n times n. The way to get our last term would be positive 8 times positive 10. And then we could check that our middle terms. That would be 10n plus 8n, which is 18n. So we have the correct factors. So up here we'll put n plus 8, n plus 10. Okay, so that gives us factors that we can cancel. But before we cancel, we need to think about excluded values. So as I'm looking at that denominator, there are some things we can plug in here that's going to make us have 0, which is going to make it undefined. So we're going to set that n plus 8 equal to 0, subtract 8 from both sides, and then we'll take n plus 10 and set that equal to 0, and n will be negative 10. So this actually, those excluded values are part of a domain. So if you're thinking about graphing this, that would be real important because there's some strange things that happen at those values we will learn about later. So right now we just want to be able to know that that's the domain. You can abbreviate that with a D. And so it's going to be all real numbers. And you could abbreviate that with a fancy R if you wanted to. I think I'm just going to use a number symbol for numbers. So all real numbers except negative 8 and negative 10. Okay, so that part is just your domain. Okay, so we factored, now we've identified the domain, now we cancel any common factors. I see n plus 10, those are identical, so I can cancel out the whole factor. And that leaves me with n minus 4 over n plus 8, and that is my final answer. So this is the simplified rational expression, and then this is my domain. Looking at number 2, we have another rational expression that we need to simplify. So we're going to factor the numerator. And we'll put our result up here once we factor. And again, since my A is 1, I only need to look at C. So I need factors of negative 24. Since that is a negative, they need to have different signs. Positive times a negative or a negative times a positive. B is 2. And if you have different signs, you actually want them to subtract to give you 2. So think about your factors of 24. 24 divided by 2 is 12. 3, that would be 8. And then 24 divided by 4 is 6. So we do need the two factors to subtract to give us 2. So that would be 6 and 4. So I'm going to put those in my parentheses. We know that's going to factor into 2 binomials. And different signs, I need to get a positive 2, so my smaller number is going to be negative. So v minus 4, v plus 6. And it doesn't matter which factor you write first because of the commutative property. Now we'll look at the second trinomial, v squared minus v minus 12. Again, a is 1, so we can just look at c. List factors, so be 1 times 12, 2 times 6, 3 times 4. And since it's negative again, we're doing the different signs, so positive times a negative or negative times a positive. And we're going to need for our factors to subtract to give us b, which is negative 1. So that's going to be the 3 and the 4. If I try to subtract the others, 6 minus 2 is 4, 12 minus 1 is 11, so that doesn't help me. I've got to be able to get negative 1. So that means my larger number is going to need to be negative. That determines the sign. So my binomials are going to be v plus 3 and v minus 4. So we'll put that in the denominator spot. So v plus 3, v minus 4. Okay, before we do any canceling, we need to think about excluded values. So I'm going to set each one of those values equal to 0, subtract 3 from both sides, and I get v is negative 3. And then v minus 4 equals 0, add 4. Add 4 and I'll get v equals 4. So these are going to be my two excluded values for our domain, and I'll just put a large D there for domain. And then it's all real numbers. I'm just going to put a fancy R for all real numbers. And then except negative 3 and 4. Now that we've taken care of excluded values, that's our domain, which would be real important if we had to graph it. Now we can think about actually canceling those like factors. So I can cancel all of the v minus 4 with all of this v minus 4. And that's going to leave me with the v plus 6 over v plus 3. And that is my final answer. Number 3 looks a little bit different because I see that my a is not 1. However, I notice I have some fairly large numbers. So I want to see if that lowest number will go divide into the other two. And I see they end in a 5 and a 0, so that means they are divisible by 5. So I want to factor that out. So we'll just divide each term by 5. That would be m squared. 25 divided by 5 is 5. Negative 70 divided by 5 is negative 14. So now we're going to focus on the trinomial and factor it. Now my a is 1. So I can just look at c. So I need factors of c. 1 and 14, 2 and 7. Since that's negative, we are going to need opposites. And we're going to be subtracting to get a positive 5. And 2 and 7 will give us 5, and I want a positive 5, so my large number needs to be positive. So in parentheses, the way to get that first term is m times m. To get that last term would be negative 2 times positive 7. So that's how our numerator is going to factor. Now we'll work on the denominator. And that's just a binomial. 5 does go into 35, so we're going to factor that out. That'll leave us with m plus 7. Okay, and I'm going to rewrite that down here at the bottom. So this is what we have so far. Before we cancel, we need to think about those excluded values. So we just look at the denominator for that. So we're going to set each factor equal to 0, but 5 doesn't equal 0, so we kick that out. And then m plus 7 equals 0. We'll subtract 7 from both sides and get negative 7. And use a capital D for domain, a fancy R for real numbers, and then except negative 7. So that's our domain. Then we can go back and cancel factors that are alike. So I can cancel 5. And then all of that m plus 7 I can cancel. And that leaves me with m minus 2 for my simplified. So in our last problem, we have this a squared minus 9, which is what we call a difference of two squares. And if you'll remember, the rule is a squared minus b squared, which factors into two parentheses, a plus b, a minus b. So a is the square root of a squared, b is the square root of b squared. And again, this only works if it is a difference. This does not work if that is a sum, only if it's subtracting. So we need to think about what can we square to get a squared? Well, that would be a times a. And then the b is what we square to get b squared, the last term. So what do we square to get 9? 3. 3 times 3 is 9. And then the rule says one parenthesis has a plus, the other one has a minus. Now if we FOIL this back out or distribute, a times a is a squared. A times negative 3 is negative 3a plus 3a. That's 0. That's why there's no middle term. And then 3 times negative 3 is negative 9. So this is the correct factorization for the numerator. So a plus 3, a minus 3. Okay, and then the bottom, the denominator did not factor. Now we'll work on finding our domain. So we'll set a plus 3 equal to 0, subtract 3 from both sides. So our domain will be all real numbers except for negative 3. Now that we have our domain, we can cancel our like factors. I can cancel a plus 3 with a plus 3. And then my final answer is a minus 3. I hope you have enjoyed this video and that you will find it helpful. If you did, please share, like, or subscribe. Have a great day.